بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على سيدنا رسول الله وعلى آله وصحبه أجمعين. سمو الشيخ سلمان بن محمد بن عيسى آل خليفة، السلام عليكم ورحمة الله وبركاته. أهلا وسهلا ومرحبا بكم جميعا في المؤتمر البحريني الدولي الافتراضي الثالث للذكاء الاصطناعي في الرياضة، الذي تنظمه الهيئة العامة للرياضة بالتعاون مع مركز ناصر للبحوث والتطوير في الذكاء الاصطناعي والمجموعة العالمية للذكاء الاصطناعي بمشاركة برنامج أنا موهوب، وبرعاية كريمة من سمو الشيخ خالد بن حمد آل خليفة، النائب الأول لرئيس المجلس الأعلى للشباب والرياضة، رئيس الهيئة العامة للرياضة، رئيس اللجنة الأولمبية البحرينية. أيها الحضور الكريم، لقد شهد القطاع الرياضي العالمي في الآونة الأخيرة تطوراً لافتاً بالتوازي مع التطور المتسارع للأنظمة الذكية والحلول الرقمية، ومما لا يخفى على أحد أن مملكة البحرين كانت ولا تزال من الدول الرائدة في تبني واعتماد الأنظمة الذكية والأساليب المبتكرة والحلول الاستراتيجية في شتى المجالات. ولقد آن الأوان لتوجيه هذه الأنظمة والاستراتيجيات لتكون جزءاً أصيلاً من منشآتنا الرياضية تحقيقاً للأهداف المنشودة. ومن خلال هذا العرض المرئي نطمح إلى تعزيز الروابط العلمية والعملية بين المؤسسات الرياضية ومتطلبات الابتكار من جهة، وتطبيقات الذكاء الاصطناعي المتطورة من جهة أخرى. أيها الحضور الكريم، يشرفنا في مستهل هذا المؤتمر أن نعرب عن خالص شكرنا وتقديرنا لسمو الشيخ خالد بن حمد آل خليفة، حيث كان لسموه دور محوري في تحقيق نقلة نوعية مشهودة في مسيرة الرياضة البحرينية، وذلك من خلال المبادرات القيمة التي يطلقها سموه واهتمامه المتواصل بمختلف الألعاب الرياضية، الأمر الذي أثمر نتائج مشرفة حققتها الفرق والمنتخبات البحرينية، وعززت من الحضور القوي لمملكة البحرين في مختلف المحافل والبطولات القارية والدولية، وساهم في تبوء مملكة البحرين مكانة مرموقة على الخارطة الرياضية. كما نشكر سمو الشيخ سلمان بن محمد بن عيسى آل خليفة جزيل الشكر على تشريفنا بحضوره الكريم. تفضلوا سموكم مشكورين بإلقاء كلمة افتتاح هذا المؤتمر.
بسم الله الرحمن الرحيم. أصحاب المعالي والسعادة، السيدات والسادة، ضيوفنا الكرام، السلام عليكم ورحمة الله وبركاته. في البداية يشرفنا أن نتوجه بجزيل الشكر وعظيم الامتنان إلى سيدي حضرة صاحب الجلالة الملك حمد بن عيسى آل خليفة ملك البلاد المعظم، حفظه الله ورعاه، على الرعاية الخاصة والاهتمام الذي يوليه للقطاع الرياضي في مملكة البحرين، وإلى صاحب السمو الملكي الأمير سلمان بن حمد آل خليفة حفظه الله على الدعم الكبير الذي تقدمه الحكومة الموقرة لتطوير الحركة الرياضية، وإلى سمو الشيخ ناصر بن حمد آل خليفة ممثل جلالة الملك للأعمال الإنسانية وشؤون الشباب، رئيس المجلس الأعلى للشباب والرياضة، على توجيهاته الدائمة لمواصلة الإنجاز في العصر الذهبي، وإلى سمو الشيخ خالد بن حمد آل خليفة رئيس الهيئة العامة للرياضة، رئيس اللجنة الأولمبية البحرينية، على متابعته الحثيثة وجهوده المتواصلة للارتقاء بالقطاع الرياضي بالمملكة. كما أود أن أرحب بكافة ضيوفنا الكرام من مختلف الدول الشقيقة والصديقة المشاركين في فعاليات النسخة الثالثة من المؤتمر البحريني الافتراضي للذكاء الاصطناعي في الرياضة. كما أن احتضان مملكة البحرين لمثل هذا المؤتمر يأتي من منطلق إيماننا الراسخ بالدور الذي يلعبه الذكاء الاصطناعي في تطوير الأداء الرياضي، واستشرافا للمستقبل الذي سيكون في هذه تقنيات التأثير الكبير في رسم العديد من الجوانب الفنية والتنظيمية في كافة الرياضات وانعكاسها على النتائج والإنجازات، حيث تعتبر المملكة من الدول السباقة لتطبيق مثل هذه التكنولوجية على مستوى العالم والمنطقة. ختاماً، نود أن نعبر عن جزيل شكرنا لجامعة الدول العربية على اعتمادها لهذا المؤتمر خلال الدورة 48 لاجتماع مجلس وزراء الشباب والرياضة العرب ومكتبه التنفيذي واللجان الفنية. كما نتقدم بالشكر للقائمين على هذا المؤتمر من شركائنا في مركز سمو الشيخ ناصر للبحوث والتطوير في الذكاء الاصطناعي والمجموعة العالمية للذكاء الاصطناعي، بالإضافة لبرنامج أنا موهوب. دعينا الله العلي القدير أن تتكلل هذه المساعي بالنجاح والازدهاد لما فيه تقدم وازدهار قطاعنا الرياضي. والسلام عليكم ورحمة الله وبركاته.
نثمن عالياً كلمات سموكم الراقية ودعمكم المتواصل للمبادرات الهادفة. أما الآن يتفضل مشكوراً ضيف المؤتمر سعادة السيد مصطفى مجدي، مساعد وزير الشباب والرياضة للشؤون الاستراتيجية والمعلومات بجمهورية مصر العربية الشقيقة، لإلقاء كلمته بهذه المناسبة.
بسم الله الرحمن الرحيم. نيابة عن معالي الأستاذ الدكتور أشرف صبحي وزير الشباب والرياضة بجمهورية مصر العربية رئيس المكتب التنفيذي لمجلس وزراء الشباب والرياضة العرب، يسعدني أن ألقي كلمة سيادته. السيدات والسادة الحضور الكرام، السلام عليكم ورحمة الله وبركاته. يشرفني أن أشارككم اليوم في أعمال المؤتمر البحريني الدولي الافتراضي الثالث للذكاء الصناعي في الرياضة، في لحظة فارقة تشهد فيها الرياضة العالمية تطورا غير مسبوق بفضل التحول الرقمي، حيث بات الذكاء الاصطناعي أحد الأعمدة الرئيسية لإعادة تشكيل كل جوانب المنظومة الرياضية. وفقا لأحدث التقارير الدولية، بلغ حجم سوق الذكاء الصناعي في الرياضة عالميا نحو 1.03 مليار دولار أمريكي خلال عام 2024، والمتوقع أن يتضاعف ليصل ل 2.61 مليار دولار بحلول عام 2030 بمعدل نمو سنوي مركب 16.7%. النمو الهائل ده بيؤكد إيمان المؤسسات الرياضية بأن الذكاء الاصطناعي مش بس رفاهية تقنية، بل أصبح ضرورة استراتيجية في صناعة القرار وتطوير الأداء. ويأتي انعقاد هذا المؤتمر تحت عنوان يحمل رؤية استشرافية واضحة من خلال 3 محاور رئيسية تجسد أبرز تطبيقات الذكاء الاصطناعي في القطاع الرياضي. المحور الأول، المؤتمر هيناقش كيف أصبح الذكاء الاصطناعي أداة فعالة لدعم اللاعبين والموهوبين، لأنه اكتشاف الموهبة ما بقاش يعتمد بس على العين البشرية أو الخبرة الفنية، بل أصبح بإمكاننا إنه من خلال تقنيات زي الماشين ليرنينج وتحليل الفيديو المدعوم بالكمبيوتر فيجن بتحديد السمات المهرية والبدنية للاعبين الصاعدين في سن مبكرة بدقة عالية. تجارب أوروبية حديثة ساهمت هذه الأدوات في تحسين فرص اكتشاف الموهوبين بنسبة تجاوزت 90%. كذلك أدت خوارزميات التنبؤ بإصابات اللعيبة إلى تقليص نسب الإصابات المزمنة في بعض الأندية المحترفة بنسبة 28% بفضل المراقبة المستمرة للأحمال والتدريبات والمؤشرات الفسيولوجية. المحور التاني المؤتمر بيتكلم على تطوير أداء المدربين والإداريين باستخدام الذكاء الصناعي، وده الحقيقة مجال إحنا بنرى فيه تطور كبير في السنوات الأخيرة. آه، أكتر من 67% من الأندية الاحترافية في أوروبا بتعتمد على أدوات الذكاء الاصطناعي لتحليل المباريات وصياغة الاستراتيجيات والتعاقد مع اللاعبين، وبتشير بيانات من دوريات أوروبية إلى أن استخدام نظم دعم اتخاذ القرار ال DSS بيؤدي رفع كفاءة الخطط التكتيكية بنسبة تتراوح من 20 ل 30%، وبيساهم في تحسين النتائج وتطوير طرق اللعب ورفع فعالية الحصص التدريبية. في المحور الثالث الحقيقة بنسلط الضوء هذا المؤتمر على أهم جوانب الرياضة الحديثة، هو التفاعل الجماهيري، وهو الفان انجيجمنت اللي ما بقاش جمهور مجرد متفرج، بل أصبح شريكا مباشرا في التجربة الرياضية باستخدام أدوات تحليل المشاعر وتقنيات تخصيص المحتوى. ونجحت أندية كتيرة في العالم في مضاعفة تفاعل الجماهير عبر منصاتها الرقمية. وإحدى الدراسات بتوضح أنه الحملات التفاعلية المدعومة بالذكاء الاصطناعي رفعت معدل التفاعل بنسبة 45%، وسجلت منصات البث الذكي المعتمدة على تقنيات التوصية الذاتية اللي هو ال AI Powered Recommendation Engines نسب مشاهدة أعلى بنسبة 32% مقارنة بالبث التقليدي. السيدات والسادة، إن الذكاء الاصطناعي لا يمثل فقط قفزة تقنية في عالم الرياضة، بل هو فرصة حقيقية لتقليص الفجوة بين الطموحات والواقع، بين المواهب والفرص، وبين الجماهير ومؤسساتها الرياضية. ومن هنا فإننا في مصر نولي اهتماما بالغا بتبني هذه التقنيات، ليس فقط على مستوى تطوير الأداء، ولكن أيضا في إدارة المنشآت وميكنة الخدمات وبناء منظومة رقمية متكاملة. واسمحوا لي في الختام أن أشيد بالعلاقات الأخوية والتاريخية بين جمهورية مصر العربية ومملكة البحرين الشقيقة، والتي لطالما شكلت نموذجا للتعاون البناء في مجالات الشباب والرياضة. وقد نجحنا في الفترة الأخيرة في إطلاق عدة برامج تبادل شبابي وتنظيم ورش عمل ومبادرات مشتركة انعكست آثارها الإيجابية على الشباب في البلدين وعززت من روح التكامل العربي. أجدد شكري بنيابة عن الأستاذ دكتور أشرف صبحي وتقديري لمملكة البحرين الشقيقة على هذا التنظيم المتميز، وأتمنى أن يسهم هذا المؤتمر في بلورة توصيات قابلة للتطبيق تقودنا جميعا نحو رياضة عربية ذكية مستدامة ومتصلة بالعصر الرقمي. والسلام عليكم ورحمة الله وبركاته.
نشكر جزيل الشكر سعادة السيد مصطفى مجدي، مساعد وزير الشباب والرياضة للشؤون الاستراتيجية والمعلومات بجمهورية مصر العربية الشقيقة، على كلمته. حضورنا الكريم، يشرفنا الآن دعوة الدكتور جاسم حاجي رئيس المجموعة العالمية للذكاء الاصطناعي لإلقاء كلمته، فليتفضل مشكورا.
السلام عليكم ورحمة الله وبركاته. Good morning, ladies and gentlemen. بسم الله الرحمن الرحيم. رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي. صدق الله العظيم. سمو الشيخ سلمان بن محمد آل خليفة، نائب رئيس الهيئة العامة للرياضة، سعادة الدكتور عبد الرحمن بن صادق عسكر، رئيس التنفيذي للهيئة العامة للرياضة، سعادة السيد مساعد وزير الشباب والرياضة في جمهورية مصر العربية الشقيقة، أصحاب السعادة سيدات والسادة، يشرفنا لثالث سنة تحت رعاية سمو الشيخ خالد بن حمد آل خليفة حفظه الله، نائب رئيس مجلس الأعلى للشباب والرياضة، رئيس الهيئة العامة للرياضة، رئيس اللجنة الأولمبية البحرينية، ليكون راعيا لمؤتمر الذكاء الاصطناعي في الرياضة، حيث سموه كان من الأوائل في الشرق الأوسط بل في دول عربية ودول آسيا ليرعى مؤتمر عن الذكاء الاصطناعي في الرياضة قبل 4 سنوات، وذلك يدل على رؤيته المستقبلية واهتمامه بتطوير الرياضة البحرينية عن طريق تقنيات حديثة. وأيضا نشكر مركز سمو الشيخ ناصر للبحوث والتطوير في الذكاء الصناعي تحت توجيهات ورعاية سمو الشيخ ناصر بن حمد آل خليفة حفظه الله، رئيس مجلس أمناء مركز ناصر العلمي والتقني، وأيضا سعادة الدكتور عبد الله بن ناصر العلمي رئيس التنفيذي لمركز ناصر العلمي والتقني. أيضا لا يسعني، وأنا أيضا أشكر في هذه الفرصة الأخوة في الهيئة العامة للرياضة، منهم أستاذة وفاء عون، الأخ عبد الله العلاوي، الأخ سعد شروقي، كثير من الزملاء، وأيضا في مركز الشيخ ناصر زملاء وزميلات منهم شيقة وشوق، وعلى رأسهم أيضا ثالث سنة حضورها المتميز مديرة الجلسات السيدة مهندسة دلال بحميدة وفقكم الله. I will be speaking my second part in English, but let me conclude my first part in Arabic. أن تطوير الذكاء الاصطناعي في البحرين عن طريق مركز سمو الشيخ ناصر للبحوث والتطوير بالشراكة مع الهيئة العامة للرياضة ليس كانت فقط بدايات إنما تطوير مستمر، حيث المركز قدم أكثر من 73 مشروع على مستوى البحرين في عدة قطاع، منهم النفط والغاز والألمنيوم والصناعة والمالية والخدمات الزبائن والصحة والمستشفيات. نذكر بعض النماذج منهم: ابتكار مبكر من أمراض السرطان، تطوير الصيانة في الشركات الصناعية، تقليل من تأثير الاميونيشن كاربونز على البيئة، وأيضا في مجال خدمات الزبائن عن شات بوت المتطور في التحاكي مع الأفراد. في الرياضة عملنا جاهدا على بروز بيانات متطورة، أن وجود بيانات متكاملة ونظيفة ودقيقة هي أساس تطوير الذكاء الاصطناعي في البحرين وخارج البحرين، حيث ننطلق في الذكاء الاصطناعي لمنطقة الخليج وأيضا للدول العربية لكي ننجز رؤية البحرين في جعل البحرين مركزا إقليميا لتطوير في الذكاء الاصطناعي من خلال تطوير برامج متطورة دولية في الذكاء الاصطناعي عن طريق البحرينيات والبحرينيين المتواجدين في المركز، وأيضا اكتشاف المواهب، اكتشاف إصابات، اكتشاف أمور كثيرة، حيث سوف نعمل جاهدا في مجال الرياضة مع الأخوة في الهيئة العامة للرياضة لتطوير برامج الذكاء الاصطناعي. وإذا تسمحون لي أتكلم بعض الأسطر باللغة الإنجليزية للأخوة المتحدثين والأجانب من دول أخرى. Ladies and gentlemen, dear colleagues, dear speakers from Italy, UAE, Korea, Belgium, Spain, Saudi Arabia. It's a great pleasure to have you with us. Some of you have been joining us a number of occasions on the virtual or in-person conferences in the Kingdom of Bahrain in relation to the AI. This is our third year. We started 4 years ago. It was one of its kind in the Middle East, in Arab world, and in Africa. And His Highness Sheikh Khalid bin Hamad Al Khalifa, Deputy Chair of the Supreme Council of Youth and Sports, Chair of General Sports Authority, and the President and Chair of Bahrain Olympic Committee, his vision that allowed us to prosper, to work and motivate to work through AI in different fields. Namely, we work AI in sports, AI in judiciary, AI in health, AI in finance, and many sectors. I will not repeat people who I have thanked, but I would like to also thank for the opening speech by His Highness Sheikh Mohammed bin Salman Al Khalifa, Deputy President of General Sports Authority and also the CEO of the General Sports Authority, Dr. Abdurrahman Askar. Their motivation, their support year after year and presenting the awards, patronating this under the guidelines of His Highness Sheikh Khalid bin Salman Al Khalifa, God bless him, has motivated us and put Bahrain on the map of the international AI in various areas, but mainly in sports. And today we will listen to our colleagues who are not only academies and universities and their businesses, but they also come with real experiences, with the clear recommendations, and they keep up with the momentum. I very closely follow my colleagues in this area, and I see month by month there are more researches and implementations that is done. And I think equally they have a lion's share in the development of AI in sports in Bahrain. So we're looking forward to hear from them. And with this, I will conclude and let the session to start. Thanking the team again for all the good work that we started doing it nearly 3 months ago when we started the preparations. A lot of work done in the background. أشكر الجميع مرة ثانية والزملاء مرة ثانية. قد أن بدأنا قبل 3 أشهر من الآن التحضير للمؤتمر، وهناك جهود جبارة من الجميع في توفير ونسخ المتطورة من مؤتمر الذكاء الاصطناعي في الرياض. شكرا الله ووفقكم جميعا.
نشكر الدكتور جاسم حاجي على كلمته القيمة وتعاونهم الدائم في إثراء البرامج التي تربط التقنية الحديثة بالتطبيقات العملية. أعزائي الحضور، نود أن ننوه في حال رغبتكم بتفعيل الترجمة إلى اللغة العربية الضغط على الخاصية CC الموجودة أدناه على المنصة. أما الآن حضورنا الكريم، يشرفنا تقديم أول المتحدثين لهذا اليوم دكتور سيلفيو جيانكولا، باحث علمي في جامعة الملك عبدالله للعلوم التقنية، حيث سيستعرض التحليل الزمني في كرة القدم، رحلة من سوكر نت إلى معهد أبحاث جامعة الملك عبدالله للعلوم والتقنية والفيفا. Ladies and gentlemen, I would like to call upon Dr. Silvio Giancola, he is a researcher at King Abdullah University of Science and Technology, who will be talking about temporal analysis in football, a journey from soccer net to the KAUST FIFA Research Institute.
Assalamu alaikum, Masa al-Khair. Good morning, everyone. Thank you for the introductions. Thank you for the invitations. I'm very proud and honored to be here today. Thank you in particular to His Highness Sheikh Khalid bin Hamad Al Khalifa for his patronage. Thank you to Dr. Jassim Haji for chairing this conference. And thank you to everyone who made that event possible. I am Dr. Silvio Giancola, and today I will share with you my journey in the topic of temporal analysis in football, a journey from SoccerNet to the KAUST FIFA Research Institute. A few words on myself. I am a research scientist at King Abdullah University of Science and Technology under the supervision of Professor Bernard Hanem in the Image and Video Understanding Laboratory. KAUST is based in Jeddah in Saudi Arabia and has been founded in 2009. It is a very unique and young university that is only 15 years old, and I'm currently quoting you from that white building pointed with an arrow. KAUST is aiming at high impact, and it has been recognized worldwide in many different aspects. KAUST made it to the top 10 young university, a nature index that recognizes university younger than 50 years old. Our faculty are regularly recognized for their research output, and the Time Higher Education recognized KAUST as the #1 university in the Arab world for 2 years in a row. Within KAUST, we are active in both AI and sports, and especially I have been active at the intersection between AI and sports. So in July 2024, we have opened the Center of Excellency for Generative AI that has been built upon 10 years of experience in research in artificial intelligence at KAUST. And I'm very proud that earlier this month, early April 2025, I've spearheaded and created the first KAUST FIFA Research Institute that builds upon 8 years of research in sports at King Abdullah University of Science and Technology. The KAUST FIFA Research Institute is the 5th FIFA Research Institute in the world and the only one in whole Asia so far. Today, I'm going to talk about my journey temporal analysis in football, and I will provide an outline starting from my efforts in SoccerNet, which are data sets and benchmark for football video understanding, explaining what the concept of action spotting, so the technical details behind temporal analysis in football, explain you how I advance temporal event localizations through KAUST FIFA Research Institute, and give you a glimpse of the SoccerNet Pro, a new framework for comprehensive temporal analysis in football. Let's start with SoccerNet. SoccerNet is the largest and most comprehensive datasets, methods, and benchmark for football video analysis. It stems in 2018 when I presented the first research paper called SoccerNet, presenting the first large-scale datasets for football video analysis. It now spans 7 years of research in that field, presenting methods and benchmarking AI systems in solving simple tasks with more than 25 published papers in top-tier conferences and journals. It led in 2025 in the creations of the first Chaos FIFA Research Institute. SoccerNet is first of all a comprehensive effort to understand and analyze videos in football. It is divided in 3 macro areas towards understanding the broadcast videos that are shown to the fans, understanding the fields in which the teams are actually playing, and understanding the players, which are the main actors in these sports. Within SoccerNet, we provide data, methods, and benchmarks organized around this task, such as here we can see the action spotting, which aims at temporal analysis in football, but also player tracking, or foul recognitions, or dense video captioning, effectively empowering AI systems to solve for these tasks. SoccerNet is an open source data-centric effort. We provide more than 850 hours of videos. That is more than a month long of footage nonstop. That has been annotated with more than 5.5 million annotations, whether it is actions or position of the players in the field. SoccerNet is mostly a research effort. Over the last 7 years, I had the chance of publishing more than 25 papers with a team from all over the world. In fact, SoccerNet is not a single person effort, but it's a team effort that I have started in 2018, but quickly joined by my colleague Antoni Cioppa in 2020, and a large team from all over the world. SoccerNet is also yearly competitions that empower academic laboratories all over the world, research laboratories, to compete in getting the best results in some tasks. We organized this competition for the last 5 years that provide some prizes for the best performing methods in specific tasks that we have created. This year, we have done 24 tasks ranging from understanding temporal activities down to understanding fouls. We had more than hundreds of participants this year from all over the world. In fact, SoccerNet has a broad impact. We have gathered a community around Discord and thousands of members. We share our knowledge through YouTube videos that reach thousands and tens of thousands of views so far. And we create these competitions with evaluation servers that brought more than 150 teams over the last 5 years. And these people that are interested in SoccerNet come from all over the world. We have recensed so far like 187 countries interested in the SoccerNet project. SoccerNet is also a worldwide network that comprise like a lot of partners and collaborators from all of the continents in the world. This just gives you a glimpse of our latest collaboration. SoccerNet also made it to the news, in particular in this article that I invite you to read about how SoccerNet brings AI inside the game of football. Let's move to the second part of my presentations, which is a presentation of action spotting, temporal localizations of events in football videos. This is going to be a bit more technical. But I'm going to define exactly what is this task of temporally localizing events in videos. Contrary to some previous literature in temporally activity localizations, the actions in football are instantaneous. They happen in a single frame. And the objective of active spotting is to identify the moments when these events occur, whether it is a corner, a card, a substitutions, or an offside. As an input, the system, this AI system, is supposed to understand broadcast videos as they are shown to the fans, has a black box that would understand and provide with a list of timestamps anchored in the videos, providing the semantic of the information of that specific event and the score of confidence whether that event has happened or not. In the literature, there have been two approaches based on bottom-up versus top-down approaches. The bottom-up methods will be presented by Anthony in his talk later today, but it relies on low-level features that would provide information on some actions happening, like for instance on the left, where we can identify that a header happens by analyzing the distance between the ball and the head of a person. In this talk, I'm going to focus mostly on the top-down approaches, which are black box deep learning methods that takes video as an input and directly produce a set of actions anchored in time. So in the literature, I spearheaded this research line of work in 2018 when I published the first SoccerNet paper, where I created the first techniques that was able to localize in time those events. In particular, given a videos in time, we extract frames from which features are extracted using backbones, and then a windows and the learnable pooling layers will aggregate the temporal information around an action to classify whether an action happens. Once that algorithm is trained, I can run that windows through the games and identify all the events that happens in the game, in the videos. In 2020, with Dr. Anthony Chopa, we moved one step further by incorporating what we called context information, in particular temporal context before and after an action occurs. In fact, it's really difficult to identify when a goal occurs by looking only the past frames, and looking at the future is necessary to understand that at a specific time a goal happened. So we derived a specific algorithms, a specific architecture that would solve for that task in a better fashion. Successively, in 2021, I published a paper called Temporally Aware Feature Pooling, where in similar idea as the previous paper, we are splitting the context before an event and after an event by looking for semantic information contents in the past temporal context and the future temporal context to identify those events. 2022 has been the rise for a method called precise temporal spotting, which for the first time was trained end-to-end with a backbone encoder feature extractor that directly takes the videos, extracts some features, and feed these features to an RNN, a recurrent neural network, like an LSTM, for instance, or a GRU, to extract specific events happening on specific frames. This allows for very precise temporal spotting at a frame level. And most recently, the state-of-the-art methods for this temporal event localizations are TDID, which is a new temporal discriminably encoder-decoder for this precise event spotting in sports videos, where the main improvement was to create an encoder and a decoders in a unit fashions. But that may be a bit a lot to digest. So I also simply want to inform you that last year with my team, we published a paper called OSL Action Spotting, which is a unified library in Python for action spotting in sports videos. It includes all the methods I just presented you into common unified frameworks that creates backbones, necks, and spotting heads, and allow you to test all the different algorithms in action spotting that I've shown before, and from the videos, output the list of actions with timestamps. That being said, I want to introduce what type of work we have been doing and we are currently doing with the KAUST FIFA Research Institute. This basically advancing this temporal event localization. So with the KAUST FIFA Research Institute, we are interested in focusing on safety in football, in particular on the safety of headers. So there have been some studies and some change in the rules over the last 5 years for football, especially in Premier Leagues and in UK. They have found a high correlation between the amount of headers that players would do in a game or in training with a high level of concussions in their head. So in order to study those phenomena, we teamed up with FIFA to present algorithms that would help them localizing those headers in football videos, but also identifying the headers characteristics in these videos and understanding the headers biomechanics to ensure that football is still safe for kids, but also for adults. And in particular, we're interested in three main aspects for this specific project, which was how do I efficiently annotate my data? How do I cope with older footage that might have lower quality? And how can I go beyond video modalities to have better performances? That leads to the first projects towards efficient data annotations. In a paper published in 2023 with FIFA, we derived an active learning methodology for action spotting. So starting with labeled data sets on the top left, I would have a massive amount of data provided by FIFA, or you can imagine that maybe the Bahrain Sports authorities might have access to a lot of videos, and they would like to localize when specific events, when specific actions happens in those games. It could be headers, but it could be also other type of actions that you might be interested in. You might not want to label the whole data sets because this is too huge efforts to make. So you can start with smaller label data sets, maybe a few dozens of videos, and start training on algorithms to spot when specific actions happen. Then, based on this model, you can run the predictions on a new set of unlabeled data sets, on new clips, on new videos, that you will use an active selection step. We will rank the different part of the videos that would provide new informations to our models, where the models might fail a little bit, just to correct these selected clips and reduce the number of annotations that are needed. In particular, that projects for the application of headers led to 3 times less data required in order to localize headers in those videos. We tried different methods based on random samplings, entropy measurements, and uncertainty measurements. And eventually, the entropy measurements was the methods that enable us to only label 3 times less data to reach similar performances. That covers the first part, which was towards more efficient data annotations. A second problem that arises is when understanding the headers that happens in games, we would like to go back in past to identify some patterns on previous athletes that are now retired to identify if they have a high concussions. For instance, if I want to see if headers have a correlation with concussions 30 years after the players have retired, I would need to go back in time 30 years and analyze how many headers specific athletes has done. That creates a big issues because the footage of nowadays have a completely different quality than what we might have in the 1930s, for instance, in the back, in the left here. So for that, we are currently working on continual learning and task time adaptation methods that would take the models trained on nowadays footage and go back in time by adapting at test times, backward in times, our header spotting models to be able to localize headers in historical footage of the World Cup, for instance. This project is currently ongoing and our result will be shared very soon. The third aspect that I'm working on with the FIFA, the Chaos FIFA Research Institute, is can we go beyond video footage to understand actions happening in games? And the problem with the footage is that the broadcast is that this comes from a diversity of cameras. It has already been edited, and often not all the players are actually contained within the field of view of the cameras. So if we are seeing like at the center of the game, for instance, in that example, we have no clue on what are the position of the goalkeepers, for instance. So in this third projects, we want to go beyond the video modalities and use embedded sensors or cameras that are reconstructing the human pose that are already used for refereeing, for instance, for the semi-automated offside detections methods that have been pushed during the Qatar World Cup, and leverage the pose estimations and the position of the players in the field in order to understand the actions that is happening, whether a penalty occurs, whether a goal, a kickoff, or a foul. This project is also ongoing. We have some early results that will be shared and published very soon. So that summarizes our activities that we are doing with the CAOS FIFA Research Institute. Last, I would like to present you our efforts towards comprehensive temporal analysis in football, in particular with SoccerNet Pro. SoccerNet Pro is this new framework for comprehensive temporal analysis in football. This comprehensive analysis does not only focus on the localizations, localizing the actions happening in games, but also classifying if such actions, if a specific action happens, retrieve similar actions in data sets, but also describe textually what is happening in a game. On top of diversifying the type of video analysis, we also want to process different type of inputs and apply that to different applications. Let's go more into the details of that framework. First, we want to have the possibility of analyzing diverse input data. All the methods I showed before actually are using either features or frame as input data to understand the different actions. We would like to be able to understand, to run that on videos directly, being able to run that on multi-view videos from the multiple cameras that are in the field and aggregate all the information from the multiple perspectives. Or we can go with the game states, which are the player poses in time with their skeleton and their body positions in the field. Giving this input, we would like to solve for 4 different tasks, 4 different types of algorithms. We would like to localize actions, like I presented to you before with the action spotting task. But we also like to classify whether, for instance, a foul is actually deserve a yellow card or a red card to support for refereeing, or to classify if specific actions provide specific outputs. We also would like to retrieve similar actions. For instance, if I see a foul happening at a specific moment, can I retrieve a similar fouls in a historical data set to see the outcome of the decision of a referee? If I see an actions where Lionel Messi, for instance, score a goal with the head, can I find a similar actions that happen in past game? This is a type of task that covers with action retrieval. And finally, action descriptions is describing what is happening live in a game. Imagine a live commentators of the games that provides you in any language, English, Arabic, a descriptions of what's happening in the games, providing you statistics and informations about the dynamic of the game in live. Those are the 4 algorithms that we are pushing towards this SoccerNet Pro. Finally, what type of application are we looking for? As I mentioned before, the CAOS FIFA Research Institute is interested in the medical analysis for headers, but we can see beyond. Can we actually prevent injuries of players to allow them to play a safer football and for more games? Can we support officiating like the semi-automated offside detection is already doing? Can we implement some artificial intelligence that can support the decision of referees in their decision making? Can we provide advanced football analytics that goes beyond player positions, but also understanding the temporal dynamics that happens in these games? Those are 3 different applications that we are aiming at with this SoccerNet Pro project. That was a summary of my presentations. Temporal analysis in football. We went starting from my journey from SoccerNet. This is an open source research project. Then we explain the concept of action spotting, which are this temporal localization in events in football videos, up to the creation of the first CAOS FIFA Research Institute in the field of temporal analysis for football. And finally, the SoccerNet Pro that aim at bridging the gap between academia and industry by providing tools, a whole framework through libraries and through tools that would allow for a comprehensive temporal analysis in football. So all of these projects are aiming at creating an impact in the world of football. And I cannot wait to see some of our technology being used in the next football World Cups or in any leagues worldwide. With that, I would like to thank you. I shared with you also in that slide a few of my side projects that you can follow up. There is a website for the SoccerNet projects. We are organizing workshops for academic publication of papers, in particular the CV Sports, and I'm also an editor in many journals for AI in sports. And I recently started a podcast called Sports AI. And finally, a big thanks to everyone. I also wanted to mention that we are open to collaborations, so I can't wait to see more of your presentations and network with you to understand the synergies that can happen between us. Thank you very much. I think I might have a bit of time for questions. I will be happy to take any.
Thank you, Dr. Salvio Giancola, for sharing your expertise and perspectives with us today. Now we would like to open the floor for the audience questions. Dr. Salvio, there is a question. What are your practical recommendations to implement as a first stage at the Kingdom of Bahrain in the field of sports?
First of all of those approaches actually are based on artificial intelligence. And these artificial intelligence methods requires data. And when I was starting collaborating with FIFA, they are sitting on a gold mine of data. They are the organizer of all the World Cup, but their data are actually not structured. Unfortunately, the artificial intelligence methods, so those algorithms, there is a saying says garbage in, garbage out, which means if you feed them with bad quality data, you would have bad quality results in this artificial intelligence. So the first steps would be to curate the data that you have access to, bring them into some common formats, and organize them for them to be fed to those artificial intelligence methods. This, I think, is the first steps. Once that is done, I think identifying the needs of the need that you have in Bahrain would actually help identifying which application to focus on, and start with a proof of concept with using your data to see the capability of specific algorithms in specific needs, and then move on the ladder of the technology readiness level, going from a proof of concept to a minimum viable product that hopefully will lead to interesting IP that could be commercialized into governmental entities or commercial partners.
Thank you, Doctor. There is another question. What impact does the choice of backbone, for example, CNN vs transformer, have on the temporal precision of detected actions in the OSL pipeline?
Yes, it's really, really important. From my personal expertise, when I started in 2018, I was using pre-trained CNN on CNN method, CNN architecture, pre-trained on generic data. And later on, we actually fine-tuned those CNN with custom football data, and we reduced by half the error rates in our metric. Now the difference between CNN and transformers, I think, is also present. Transformers tends to be more performant than the CNN for the backbone encoders of the frames. Although I have to say there are some literature there's some literature that's been published that's going back to CNN, because Transformers has a lot of tricks that also made them improve in performances. The problem also with Transformers is that they're usually more hungry in terms of resources. So I still prefer CNN personally. Transformer can give you a slightly boost in performances, but most importantly, fine-tune your backbones. Fine-tune your backbones on sports data, football data, or other type of sports, if you like.
Okay, and do these approaches valid for other sports referees?
Absolutely, absolutely. So I've started working in football because it's the most popular sports in the world. So it was easier to attract researchers and students and academics to work in that realm. But it definitely transferred to other sports. We did a study in 2024 of transferability, not among sports, but among different leagues of football, for instance, train an algorithms trained in the English Premier Leagues and apply that in the Italian Serie A, for instance. So there is like some specific gap between the leagues, but the algorithms as they are can be fine-tuned on new sports. And it can be, for instance, applied to basketball to count how many shots has been done, how many points has been scored, and so on and so forth.
There is one more question. What are some of the promising ways AI is currently being used to enhance player safety in sports?
Right, really good questions. So I would reiterate like what we did with artificial intelligence and what type of decision. So for instance, safety for the headers, there is like a lot of correlation between headers and concussions. So AI has been here to support physiotherapists to localize and find all the headers that happens in previous World Cup. So AI is a tool in that case that can help in having a higher throughputs in the research of those physiotherapists, because instead of watching thousands and thousands of games that will take them like months and years to identify, they can, in a fraction of that time, localize all those events, all those headers, and just analyze the impact of those headers. Other directions still for the headers would be identifying, for instance, with extra sensors, the forces that are engaged. For instance, there is like a mouth guard that are equipped with IMU these days that can identify the force that an impact to the head has been done. AI could help classifying whether specific forces or specific sensory data could lead to future concussion. This is some application. There's most probably others, but I don't have much in the top of my head right now.
Thank you again, Dr. Silvio, for your expertise and perspectives, and thank you for your time. أعزائي الحضور، أود مرة أخرى أن أنوه في حال رغبتكم في تفعيل الترجمة إلى اللغة العربية الضغط على الخاصية CC الموجودة في أسفل المنصة. أعزائنا الحضور، يشرفنا الآن دعوة البروفيسور أرنستو دامياني المدير العام لمركز الأنظمة الفيزيائية السبرانية بجامعة خليفة. I would like to call upon Professor Ernesto Damiani, Senior Director of the Khalifa University Center for Cyber Physical Systems, who will be talking about data-driven machine learning models for behavior and lifestyle, the MUSA approach.
Thank you very much. So basically, I will take a very different perspective here. We are not talking about sports as in competitions. We are talking about the practice of sports. I will start a little bit by the notion that urban environment is also a place where people do sports. So in the urban environment, in the parks, but also in the streets, in the roads, you do a lot of sport activities, right? And so we are looking at the notion in which the urban scenario can be an interesting one, both for providing advice, support, and of course monitoring to the sporting activities that you can carry out, working out. So basically, this is, in a sense, one of the many functionalities that the smart cities can provide, right? And I'm not going to go through all of them, but certainly the notion that we can remotely monitor the activity that take place and provide advice and support is a general feature of a smart city compared to the traditional notion. So I'll be discussing here a project in which basically it's a European project, actually, although, of course, we have an involvement of Khalifa University, but it's a European project in the Next Generation Europe projects. And here you see all the partners of this large-scale project. It is basically for a multi-layered architecture for improving the urban lifestyle in general, both for the companies, the entity, the institutions, and the people. And I will focus on this particular part. I don't want to bore you with the details, but as you see, it's a project that puts together a number of universities plus a number of large-scale companies that are interested in both the devices, the networking infrastructure, but on the applications and the AI applications specifically. So basically, what we are at the general objective of this project is to create basically AI models on your socket access to AI models. So being able to deploy very fast and to run AI models that can be of use in the urban environment for the different applications. And we will focus on soon on the sporting side. But let me say something. The deployment of these models, of course, requires the models to do their inference, meaning to provide the results based on data that are collected from the environment, from the devices that are of the users, but also for devices that are available as part of the infrastructure at the edge of the infrastructure, and then to compute an inference that will go back to the user in form of advice, in form of support of different types. And we don't run this thing on an open internet. We run this on the 5G network in order to be able to, first of all, provide the right latency. It's you're getting advice, especially when you are working out, is an advice that you must get with limited latency, right? But also, we wanted to provide it in a privacy-preserving and confidential way. So we cannot use the open internet. We use specifically the 5G technology to create a networking environment where the data about the activities of the individuals, be they sport or not, they can be sort of certified from the confidentiality and the privacy point of view. So let me just show you the platform, experimental platform where we have been running these activities. This is based in Milan, Italy, and you see the different areas of the city that have been covered with instrumented 5G cells, where we can collect the data, transmit the data to the on-network support of the models. And the notion is that the model's inference will not be executed in a central cloud, but as close to the area where the activity is carried out in order to limit the latency of the model response. So sometimes you want a model that is able to respond in just a few hundred milliseconds. You cannot propagate the data to some central cloud application. You want to have the model pushed to the periphery, and this is the role of the 5G network. The 5G network is also, in a sense, a proximity cloud where you can run models close to the place where the user is, especially when the user is mobile. We will talk about biking, we will talk about running in a moment. So this is anyway the overall idea, and this is the test bed where we have been trying out this approach. Okay, so the target applications are not just sport, of course. We are in general talking about anything that has to do with monitoring the people activity and to the application of risk models in order to identify risky situations in which advice and support. So we have a number of applications that have to do with healthcare in general, but I will focus soon on the applications that have to do with, let's say, the lifestyle and the sport activities. But anyway, here you see the overall architecture. Basically, we have this platform for collecting the data on the edge, running the model on the edge, and the model are created and pushed to the edge from a central facility. So the idea is push the model close to the place where they have to compute their inference. Of course, all this needs to be certified. I have a little bit of self-advertisement here. This is our book on how security certification can be done, especially privacy and confidentiality, on an architecture like this, in which you have the models going around in the network. You need to continuously monitor the security properties that you want to ensure. Okay, so now let's talk about the models for a moment. So we are interested, of course, in traditional models, even the simplest one, like the regression. We are interested, of course, in classifications. Of course, we wanted to be able to perform a generic classification activity, single, for example, understanding the nature of an event has been well presented in the previous presentation, so I'm not going to go into that. I'm going to focus into the type of model that we are working on now, which are the LLMs. So basically, the notion is that the LLMs are providing support and advice. These LLMs are anyway performing a task which is very different from the classification or the regression one. They are basically answering, meaning that they are completing a prompt, they are completing a prefix, they are finding what is the right completion to an initial part, which is your prompt. So, and they can do it by taking into account not only the general training that they saw, but also some more targeted tuning data which are provided to them. And also they can take into account context data that is made available at the prompting time. So this is a little bit the overall thing that we are considering, the scenario that I will be focusing on. Although on our architecture, we have, of course, regression and classification models running as well. So the problem, of course, is that the reason why the LLM is a good model in this context to provide support and advice on the activities that are carried out by people in the urban environment is because the traditional models have a problem of data scarcity, which can be handled. I'm not saying that it cannot be handled, but certainly the LLM has a let's say, a training, a basic training that can make the model, let's say, less difficult to tune with a limited amount of data. So let's now focus on the large language models for healthy lifestyle advice that we deploy in the framework of the multi-layered urban safety architecture, the MUSA, as it was called. In Italian, we call it MUSA. But anyway, the MUSA is inspiring, in a sense, is an inspiring entity. So I hope it can inspire to a better lifestyle. So the LLMs, basically, as I told you, are not trying to classify, like detecting whether an event is of a nature of another nature, like we have seen before. They are trying to get context data and to be able to provide support and advice upon request of the user, both during and, of course, before and after any activity. And, of course, the promise is to be able to provide custom advice, which is personalized to the context and also personalized with respect to the user. So, okay, here we have several of the areas where you can try to apply this type of idea. Activity recommendation is the one that we'll be talking about, dietary advice, environmental alerts, all these type of things. So let's go back for a second on how the LLMs work. So basically, what they are doing, they are providing the best possible answer given their training. And you know, the notion is that the error that is used for training this model is not the factual error. It is the error in terms of the quality of the completion task. So the best answer doesn't have to be, unfortunately, doesn't have to be the factually correct one. If an LLM has heard something wrong, it may repeat it. And in this area of recommendation and advice concerning the physical activity, you have to be very careful about the quality of the thing. So of course, the notion is also that when you provide the context to the LLM, you are providing an addition to the prompting, the question of the user, and that context is the very important part because there you can act in terms of the customization of the model. So let's recall very quickly how this thing works. So you have what is the best duration for a biking exercise at 29 Celsius? Remember, this question per se will get a very generic answer. I will show you it in a minute from any LLM. The notion is that, of course, you don't have only the prompting here. You have even if the prompting looks like generic, you have the context information that can be transparently added to the prompt in order to trigger a customized response. And of course, I show you here that basically the model is transforming the prompts into a vector representation. And this vector representation is the key of it all in a sense, because it is mapping the words into tokens that have, let's say, not a strong, they have a closeness between each other. The closeness of the tokens is in a semantic space. So even duration and the time are basically close in terms of the tokenization, even if they are far away from each other in terms of string distance. So here you see a little bit what is the thing, and I'm showing you just for the difference between what you get in the ordinary free market and what can be delivered by the specialized modeling that we propose. You can see in Musa, you can see here the generic answer that is given by Copilot from to this question. And of course, there's no context here. So being no context, the Copilot doesn't know who is asking, doesn't know when the question is being posed, does not know what are the context data. So the recommendations are very general. Now let's see a different scenario in which you want to deliver a service like this. So here you have the Cambio network. This is the network of the biking facilities that you have in the city of Milan. And so you see the different colors will identify different features of each of the biking scenarios. So basically, when I ask to the system, what should I do? What is the exercise that I should have? And I can do it while I am before leaving home, or I can do it while I'm biking around. The system will take, the LLM will take into account in its advice two areas. One is the person, the context, user context. Second is the user geographical context and the position. And thirdly is the state of the available network of places where you can do your training. So what are the benefits of putting down an infrastructure like this? Of course, you will make the investment in the urban infrastructure. And of course, this is also part of the project. The investment in the Cambio network is part of the project. It means that the different areas in the city are now being converted in order to support the workout activity. But the intelligence of the system and the provided advice and the guiding the people it gives you a sort of additional value, boost the value of the exercising infrastructure. So this is the overall notion that we are carrying out. And the infrastructure is intelligent infrastructure, customized advice, customized support can help to boost the value and to ensure that the investment made in making the urban environment also usable for sporting activity comes back in terms of results, improved public health, enhanced quality of life, and of course, also the urban planning. Of course, there are challenges. As I told you, the data privacy, and mostly we do this by using the 5G network rather than the open internet in order to carry the information, the prompting, and the context from to the internal models and down the advice to the user again. The integration with the infrastructure, of course, the Cambio infrastructure is a recent one. It's being built gradually. And so the notion that it can be intelligent, meaning that it can have customized agents for advice in using it, is so somehow natural. But if you are looking at legacy infrastructures, this approach well, it has to be adapted and integrated. And of course, the data accuracy and reliability. Again, it would be very hard to train a traditional predictor. So the notion that the LLM can provide, let's say, valuable support with respect to the traditional predictor models has to be sort of validated. I will come back to that in a second. Okay, so now the context data. The moment the context data, we have only partial integration of the context, the user context, in terms of the static values of the user profile. But of course, in theory, the model could take into account the current situation of the user in terms of wearable data collected from the wearable. So this is something we are working on. integrating the devices data, the personal monitoring devices data into the user context in order to make the advice even more customized to the specific conditions, not just on the age of the user, on the previous experience in terms of exercise, but also on the current situation in terms of the healthcare of the signals that are collected through and centralized to the phone. This is more easily said than done. There are many applications like that, but run by commercial equipment, they have the generic notion of being able to record the data about your past exercise, but almost no one is offering a runtime advice based on the current data from the wearables, because there's a lot of problem in terms of making sure the data are reliable, making sure that the data are connected. So at the moment, we are looking at how this can be done. So what is the benchmark? Of course, the benchmark for studying the quality of the LLM provided advice with respect to the traditional model would be, for example, to use simple models for providing advice. Like, for example, the duration of an exercise could be the result of a linear regression. And of course, there's been a lot of, I'm showing you a nice paper in which the notion that how can you sort of advise the duration of a specific exercise based on the static information available about the user shows that the regression, what are the performance of regressors in this area. And of course, there is a higher variability. Unfortunately, the simple models will have problems in handling the context. What we are looking at in the LLM is not that much to be more precise, but to be, let's say, sensibly more generic, which is basically how the LLM will handle the context data, will not trying to provide a specific quantitative estimate, but will be to provide sensible advice. So I would like, anyway, to conclude this talk with sort of an homework exercise. Sorry if... So now, suppose that you wanted to... this environment, the environment that we propose, is also an environment for innovation, meaning that you can propose a lot of apps, vertical, that only do a specific thing, provide a specific type of advice. For example, you could imagine that there is an app that gives you the safety of biking exercise, giving the user profile and the temperature. This is one of our first, let's say, mental experiments, in which you basically are getting from the overall model, a recommendation. And this is a traditional model. The LLM, in this case, could be used simply to automate the labeling, because it would be very difficult to come up with training data for the model, for a traditional model, come up with data which are actually sampled. You can sample data, yes, but labeling them would be a very big problem. So maybe I can use the generic LLM model that gives me advice in order to provide the labels for the vertical model, a simple classifier, binary classifier, safe, unsafe, that will just use it to maybe to paint the color red or green, the journeys on the map for the Cambio network. So suppose you do this. This is, technically speaking, not particularly sophisticated from the technical point of view, but you have the problem that you are basically inserting the manual, the automatic labeling will create an additional risk. And the risk needs to be assessed before introducing this particular functionality. So the notion is that the regulatory environment is another reason why you have a problem in providing this type of very precise advice. So the EU Act, the EU AI Act requires assessment of the risk of providing the customized representation. So this is why we are looking at, let's say, precise but not too precise recommendations. Okay, I'm going to conclude here. First of all, the urban environment can be instrumented in order to provide advice to people based on their behavior, based on their history, based on their the static data, and based on their intentions or prompting. This can be done through specialized LLMs. These LLMs need to be trained, but even better, the input to these LLMs need to be manufactured in order to get the type of advice which is customized enough to improve the general collective results, but not too precise to create liability profiles that wouldn't be acceptable from the regulation point of view. So at the moment, the project will deliver the prototype in February 2026. We have already a lot of interim experiences to share. And of course, we are also interested in general collaboration between people interested in the upgrade of the urban environment for being the place where people can be assisted in their lifestyle decisions. Thank you very much for listening, and this ends my presentation.
Professor Ernesto Damiani, thank you for sharing your expertise and insights. Now the floor is open for any questions from the audience. Professor, how we can develop closed LLMs tailored for the athletes in Bahrain to deliver personalized guidelines and information on sports safety and health?
Yeah, the problem of tuning the LLMs to the specific situation is a very important one. First of all, you have to ensure the alignment of the LLM training to the regulatory framework. You have to assure the alignment of the LLM training to the specific general notions. So instead of having only a single context, you have also some general context that instead of adding it to the prompt, as we do for the individual context, you can add the country context or the regulatory context needs to be added to the model in the tuning phase. So at the moment, we are doing exactly like this. The technical addition of let's say, general city or country-wide context to the model to customize it to Bahrain, which is a different thing than prompt editing to customize the answer to the user. These are two different things. So this tuning, we do it through basically, it's very simple. All you have to, it looks simple at least. All you have to do is to find the right context information description. You have to chunk them JSON LM in order to be part of the tuning of the LLM. And then you have to do the chunking right, because this context information needs to be provided in semantically coherent units. Once you have done that, you tune the model. There are many tools that you can use, and you will get a model that is aware specifically and in a special way of the context, general country context information that you provided. So this is something that we do. And of course, then you need to be able to compare the tuned model with the vanilla open. It's easy to do if the model is open source. You just there are many tools to do that. You can compare that the model has actually digested the context the country context information that you wanted to give it to this model. So this is very unfortunately, it is more an art than a science. You need to have a good group that can collect the country context info, regulatory and advice and guidance information. You can transform it into the tuning material for the model to be specialized.
Professor, thank you. There is one more question. How can the integration of IT and smart infrastructure and environmental monitoring help cities become more sustainable and resilient? Maybe it's not related
but it's
directly to sports, but
no. This is the general thing we do in Musa. We have the place where we can train the models, And then we have from this contract, let's say from this dashboard, we can push the model into the 5G network stations so that the models can be executed close to the action. So this is the main thing that makes the main difference between applying AI in you see in a cloud-based setting where you have data, clerical data, tabular data, images that are collected and then used later, from real-time inference. Real-time inference, you need to be able to run the total part or a part of the inference close to where the input is collected. And this is in smart city is typically a place where you are able to push partly or totally. At the moment, I discussed only totally, but of course, it can also be just a part of the model to push it where it is needed to minimize the total time of the inference. This is the smart city needs to be instrumented like this. Otherwise, you cannot have real-time inference of artificial intelligence model. You cannot bind the inference to, I don't know, 200 milliseconds, 300 milliseconds, 1 second, which is what you need when you provide real-time advice to people. In a number of areas, of course, autonomous driving, advice and monitoring physical activity and lifestyle is just one of them.
Okay, there is also one more question from Mr. Sahid. Professor Damiani, with the Europe Union, recent initiatives like the establishment of AI factories and gigafactories, how do you envision these infrastructures influencing collaborative research and innovation in AI across Europe? Specifically, what opportunities do you foresee for researchers and institutions to engage with these centers to advance AI applications in areas such as sports analytics?
Yeah. I am already doing something like that here. We have a collaborative project, for example, between European University and Khalifa, and we bid for training time on the supercomputer infrastructure that the European Union has created. So you can bid for the spare time, because that is for training, not for the inference. The inference you have to do it real time, but the training and the tuning you do it on so you can bid. And this infrastructure that Europe is creating is not just for Europeans. If for everyone who wants to, for example, from the UAE, we are already running several large-scale training. Even if the UAE, we have a big capacity, but it's very costly. So the nice thing about Europe is that you can apply, and they give you the training time for free. So what we are doing is training these models on the infrastructure, on the large-scale infrastructure, to minimize the training time also. Because, of course, you have the inference time to minimize, but also the training. So Europe is providing an alternative to US-based training infrastructure. And I think that this alternative is also interesting seen from the Gulf region. Although the Gulf region itself is also investing heavily in its own infrastructure, but it's never enough, frankly speaking, from the point of view of having the capacity, and to quick training can make the difference between an idea, business idea, and something that doesn't get any result.
Okay, Professor, there is also one more question from Mr. Ayman Khazraji. To which extent the usage of LLM in sport would be unbiased, especially from the point of view of the losing team? This risk raised many discussions during presidential polling. I mean the usage of technology in such cases.
Yeah, I do entirely agree, and I also detect a hint of humor in this question. So it's also very smile. Yeah, this is one of the big problems that you want to do, limiting bias, and we have the monitoring infrastructure that we have is basically something that is used prior to putting the model into production. Putting the model into production means that the model will be used for real-time inference. Before that, we run a series of dialogues. It's dialogic type of checking. And this is part of the monitoring infrastructure that I showed. So you are responsible for the verification. There's no a priori way to limit the bias. There is a good way to periodically run verification. So the models are continuously monitored for bias, known bias. Of course, the problem is that sometimes the bias emerges with respect to checks that you didn't even envision. But in the case of sports, you know the teams, you know the perspectives, so that you can create a verification suite that can be run periodically after every update to the training of the models. So this is what we do. We do not try to limit a priori, but we have a verification methodology a posteriori.
Professor Ernesto Damiani, thank you very much for
Thank
sharing
you.
your expertise and insights.
Thank you very much.
أعزائنا الحضور، قبل الانتقال إلى متحدثنا الثالث نستعرض عليكم طريقة تفعيل الترجمة عبر المنصة. Moving on، ننتقل إلى المتحدث القادم، السيد بيدرو ماسترينر، الرئيس التنفيذي والشريك المؤسس لشركة هورايزن. سيستعرض علينا دراسة حالة لنماذج التطبيقات في مجال الرياضة. Ladies and gentlemen, please allow me to call upon Mr. Pedro Mastriner, CEO and co-founder of Horizon, who will be sharing a case study of application models in sports.
Thank you very much. Thank you once again for the opportunity. It's great to be here again. First, I would like to thank everyone for setting up this event. It's a fantastic opportunity. Thank you, Your Highness, Dr. Jacine as well, and the whole team around to make this happen again. It's a lot of work from everyone and all of you. So thank you very much. I'm going to share my screen and let's go for it. I'm going to take, as you're seeing, a different approach on that. And before I'm going to introduce a little bit of what we're doing and myself. So basically about myself, I'm a computer engineer with background in AI back in the 90s when AI was, I would say, boring to study a little bit. And there was not enough data or computer power probably to do what we are doing today. And as my colleagues, Dr. Ernesto and Silvio were mentioning, a lot of opportunities around that. So I'm going to take also a different approach here, directly to a case study and more practical. And now that we have this, more background on more the models and LLMs and the whole infrastructure behind that. So on Horizon, basically, we are a 5-year-old company, sport tech company, focused on literally transforming social media content from sports into revenue. So I'm going to explain later what that means, but basically using AI to value pack and monetize content from social media from all over the world. Currently, we're working with 143 clients from US MLB teams to the Australia Open, going to cricket in India, football in Spain, Real Madrid, Arsenal, Football Club, Chelsea, and others. Basically, we were operating 20 different sports. So not only football, 50% of this is definitely football, and around 25 different countries, basically. In terms of data, just to give a glimpse to start of this, we analyze around 4 trillion impressions every 12 months and nearly 100 social media posts from Instagram, TikTok, LinkedIn, so the Meta combined. And yeah, we have enough data here to show a little bit of what we're doing here instead of getting the more technicality. So just to give some context today, in the world of sports, football teams, leagues, and federation, they need to live based on the rights, commercial rights, media rights, and naturally sponsorship, which is our expertise, is a big part of that, a big chunk of that revenue model. What's happening in the world today, it's brands, Coca-Cola, Visa, MasterCard, you name it, are spending more than 50% of their advertising budget in social media. The second thing is that social media content in sports are generating sometimes 20, 30, 40 times more engaging than a traditional Facebook or Instagram advertising, comparing to this. However, the sports organization, athletes, influencers, as we call anyone with an audience in social media, are only monetizing 5% of that content on average. 95% of that fantastic content remains unsold for the right holder, for the sport organization. Social media platforms naturally are monetizing this indirectly through algorithms and other forms of advertising. So what are the problems we are trying to, so today, again, we're going to do a very simple problem, solution, and case study to make it simple also for the audience. So the biggest problem the sports organization, well, they need naturally to keep increasing revenue. Not only inflation, but also players' cost, infrastructure cost, everything is on the rise. And naturally, revenue needs to be increasing to support that. But definitely, a sport organization, they do not have the ability to value their content. They are a sport organization, naturally. They not understanding too much about their audience, and they're focused on the past way of measuring everything, which is basically media exposure. On the other hand, the other part of this equation are the brands. So brands are basically not understanding what is going on with their investment on traditional sponsorship. There's a little bit of lack of transparency in general of pricing and KPIs because of different models, different valuations. And why all this is happening? Again, social media is taking all the attention, as we can see here on number one. Basically, actually, Meta is about to have a largest revenue than all the TV combined in terms of advertising globally. So that's number one. And number two, everything that the agencies are doing manually, according to our colleague here, Sam Altman from OpenAI, is basically the agencies will be automated in the next 4 or 5 years. So they need to invest actually on that IP. On number three, basically the audience already shifted from TV to social, or as we call digital formats. Everyone, doesn't matter, regardless the millennials, Gen Z, or whatever we're going to call here, already shifting to digital, and definitely social. It's already surpassing the 50% in terms of content. And the number four, which I mentioned before, brands are boosting. This is just a recent information. Unilever is one of the biggest, consumer brands in the planet, are boosting their expenditure in more than 60% actually to, as we call, digital influencer, everything on that angle. So with that context, there's a solution we're providing using AI, which is basically, I'm going to give you the example now, but identifying through thousands of social media content by each of the organization they're producing every year. So we can identify that content, we can pack using different models. So for example, every time there's a goal or a celebration in football, or the man of the match, or the woman of the match, or the birthday content, we can value this, detecting that content automatically. We can value that content by using models of valuation on media exposure that I'm going to show in a minute. And we can basically provide analytics on that performance, not only on engagement, but impressions. We have 25 to 30 different let's call analytical points. I'm just putting here engagement to make it simple. So basically, we are providing new revenue streams for the right holders, whatever sport they are working with. So in terms of AI capabilities, trying to avoid here more technical, but just to understand the way this operates, we are basically not only for our clients, but across the industry, scanning around 7,000 sports properties data on social media literally every day. So that's not only one way of collecting the data. We have our market scanner basically across every sport, every single right holder. We also having our audience enrichment to understand what is the profile of that football team or federation or athlete or talent or influencer, it doesn't matter. And then of course with some third party or first party data that we can enrich that, let's call database. And then from that we can build and put our, let's call AI, and not only AI tech capabilities, either is valuation, either is media exposure and logo traction, which I'm going to give an example. And from that, we can build several products from analytics purely, so descriptive analysis of what's going on, from predictive, so the planning, and benchmarking what is going on with the Lakers in the NBA versus the Manchester United in terms of performance of social media. And naturally, to automate that process is to monetize, help them to either pack, bundle, or unbundling sponsorship packages so they can be more efficient in terms of selling this. No? So how this works in a very simple example, you have social media. I took here Williams Racing. As you can see, they have tons of content, tons of brands here on the right side from, Duracell, Betway, etc. So how to measure that exposure, how to measure this in an efficient way and use a proper evaluation methodologies. So you can see here, so the computer vision basically detect the brands. So to do this, and I'm not going to again go super technical here. I think Dr. Silvia knows this better than us probably. But basically, we train the machine in order to detect the brand. I think that's one parenthesis I want to make the technical thing here. 3 years ago, to train those brands, you need at least 300, 400, even 500 samples of that particular brand. So let's call the model can understand that is precisely Duracell, for example. Nowadays, you can train those models with 3, 4, sometimes 5, or even less number of logo samples. No, so the capacity of trained models, it's increasing. The capacity of computing, it's much more powerful. So allow us to have in our system today 7,000 brands that are already trained. So basically anything that we can put now, and I'm going to show here an example. As you can see here again from Williams Racing on the bottom right side here, we're going to see different formats, different size, different shapes from Duracell showing up, and they just pop it in and the system keep tracking this. So those seconds that is showing up that video, it counts in the model and basically apply evaluation for that, which basically on CPMs, according to geolocalization, etc. No? So again, just to make that a simple case, we're working with Arsenal Football Club, and basically, as you can see, some examples here, the content they are producing basically on social media, their organization literally can, the mindset is basic that it can be monetized, either, for example, through the t-shirt of the sponsors that they're doing, but also on social media, putting content powered by or sponsored by. So basically, it is an example of football organizations and others, which are basically, taking their content, understanding what they worth in terms of value, packaging, understanding this properly, and showing a little bit to the brands how can they deliver this, comparing to a traditional advertising. So Arsenal is one of our clients for the past 4 years, which are taking tremendous advantage of the technology on the commercial side. So this is not on players' predictions or anything else. It's purely using volumes of data, basically hundreds of different content types on social media, where you can put a price tag on this, and eventually, if they strategically commercialize this to a right holder. And I stop here. The idea was basically to give some very simple problem solutions so we can, on top of the whole more technical things, show that AI is impacting not only on the players, on the video reviews, on performance, on injuries, but also on the commercial side of the business, which is, again, a very important piece of the whole process, especially now where, content is still the king on social media, and our user or attention is very fragmented due to the amount of content being created. So definitely also part of what we do is to identify which content are the best performers and where and what it's engaging particularly audiences, either they are in Middle East or in Latin America or here in Southern Europe or in the US or in part of the world. So you can adjust your content strategy to either generate more engagement, naturally generating more value, hence you can monetize this properly. So without, as we call, AI and any other capacity and capabilities for the commercial team, will be completely blind and selling basically stickers around. This is over. It's a saturated market in terms of content. So identifying using AI to, separate everything that is not performing well from what is performing is our goal, and helping right holders, from talent, from anyone who can own an audience basically in social media. And I stop here my share, and I'm open for any questions. And thank you once again for the opportunity.
Thank you, Mr. Pedro. Let's check if there is any question from the audience. There is for Mr. Sahib again. He's saying, it caught my eye that Horizon is working with Riot Games, which I found particularly interesting given the unique dynamics of the esports industry. With that, what challenges and opportunities have arisen from applying traditional sports digital strategies to the esports domain?
Yeah, that's a very good question. Thank you very much for doing that. The esports, naturally, the audience was born, as we call, digitally, so they understand better than us in terms of what is going on social. So in particular case of Riot Games, everything they're producing on social media, they're using to understand what is working, what is engaging, or what is not engaging with the with the audience, with the fan, with the particular club, basically on the esports. And secondly, they are packing this to monetize to eventually sponsors, new sponsors, not only current ones, but for bringing new, as we call, digital sponsors. So we are solving content production analysis and, as we call it, sponsorship, either traditional one or bundle for digital.
Okay, there is one more question. Are the recommendations presented by you are cost effective that can be implemented across various sports?
Yes, yeah. To answer that, we are already operating 25, 26 sports. It doesn't matter the sport. What we do, we train the model not only for the categories of content, but also something that I haven't shown you is about the location of the logos. So of course, in Formula One, you have the helmet and the drivers. In baseball, you have the hat or any other part, or football, you have the t-shirts, the shorts, or the shorter turf. In volleyball, you have different appearance. So basically, it's just training models. Now with the model, we just basically, okay, if there's a new sport coming in, I don't know, table tennis or something, we just train the model and showing what we have. There's a racket and there's a logo in the racket. We can also train. That's the beauty about scaling this once you have the first one developed. No?
Mr. Pedro Mestriner, CEO and co-founder of Horizon, thank you very much for your time.
Thank you very much.
Thank you for your
Thank you.
insights.
Thank you.
أعزائنا الحضور، ننتقل الآن إلى الدكتور تشان يون، رئيس قسم الأمن السيبراني بمركز الأنظمة الفيزيائية السيبرانية بجامعة خليفة، حيث سيستعرض علينا تطبيقات الميتافيرس والبلوكتشين في الرياضات الإلكترونية. Ladies and gentlemen, let me please call upon Dr. Chan Yoon, Cyber Security Leader of Center for Cyber Physical Systems, Khalifa University, who will be talking about metaverse and blockchain applications in esports.
Yeah, thank you very much. First of all, I'd like to thank all the audience and organizing another very nice online AI Expo. And I very much appreciate Dr. Jassim for that, and also His Highness to oversee all these activities. Of course, my talk is all about AI in sports, but in the different perspective, I will introduce blockchain-based asset management application in the esports. Also, we'll talk about the metaverse environment as well. So let's tackle it one by one. So this is the content of my talk. Introduction, the AI in sports, and fitness for duty in the, or at least whether he's fit to like compete the activities or not, and also using this AI techniques. And also I will discuss about blockchain technology and managing data monetizations, and also we'll talk about challenges in esports and what can be applied in the esports. Actually, esports is coming into, you know, this like increasing a lot of activities in Saudi Arabia and all of the world, and I can see that also it can be applied, and also I will discuss about in the metaverse environment, because metaverse is coming to, mixed reality, augmented reality coming together. So it will be very useful application in this area for esports. Right. So without further ado, and the introduction, as you can see, the athlete, you have to consider the real life heroes and represented in the participation. I think the previous the speaker mentioned about Messi. Everybody love football, so therefore they want to participate and support in the esports as well as the real sports in football. Okay, so and we want to make sure that mental fitness is very important. Physical fitness is also important. However, also same time the mental fitness is also important in the sports. So I will talk about that in more detail over here. Of course, as I mentioned, mental health. At the end of the day, everybody want to win, and therefore there is stress. Of course, the nowadays in the sports days, unless you won the gold medal, silver medal and bronze medal are forgotten. So that's why people are very much stressed in this area. And whether you can able to cope with performance, and of course at the same time, and remember that people use drugs and things like that for boost up the performance, physical performance, and things like that. So we need to make sure that verifying the athlete's mental fitness using AI technique can be very, very, very useful. And this is one of the reference that I quoted over here. And also, AI in sports, we can see that the evolution of the mental fitness of the athlete is important, and so that we develop very interesting fit. We at Khalifa we start with the fitness for duty in the national critical infrastructure, but it can be same thing can be applied in the mental fitness in the esports or the actual sport itself. So this is very intriguing and the area, and also not only we need to evaluate, but also evaluate fitness ability and improve sports performance, and the increasing the high density training and so on, and this causing the mental degradation and also the tiredness and things like that. Also, we need to consider this, and some of the paper is already published in this regard in the AI, the verifying athletes' mental healthness in the AI techniques. Okay, right. So AI athletes. AI in athletes fitness evaluation. As you can see that there are many ways of metrics to wear it, because we wear wearable. For example, I think the previous speaker, you mentioned about garbage in, garbage out. So you need to collect data. Of course, FIFA World Cup, they have a lot of data, but it have to be clean. Not only clean, but also it is labeled data or not labeled data. We have to make sure that the data is what you want at the end of the day. So where do you collect? Collection is very important. Like wearing the wearable, like watches or the band or vest. They have a heartbeat. Like for example, you have an ECG. And also when you move, there is a lot of sensor you can have. Therefore, you can able to create the heat map. I think the previous speaker mentioned about heat map in the football World Cup and so on. So you can create heat map for the athletes, like football players, when they move to he's a winger, for example. Then the winger side is more heat map than the defender side or the forward. They can analyze this and how the heat map is moving in order to prove that. At the same time, also can consider whether when you detect the heartbeat and so on, the ECG, and you can prompt that these players are a bit stressed. I think some athletes in the too much stress, and they got the heart problem, and some of the students, some of the athletes went to hospitals and things like that. So it depends on that. So, and let's look at how this is work. So of course, I think somebody already mentioned about deep learning and also CNN, of course, and especially is visualization. I think it's very important to use CNN. However, recently, and there is a vision transformer. Vision transformer is one of the upcoming area that I believe that it will be, change the recent research, because CNN is old, but vision transformer is new, and there is some advantage and disadvantages. However, the vision transformer is very good for, like, you don't have to label it. It's already labeled. But however, there are pros and cons for that, so you need to consider this. Okay, and we didn't use transformer yet, but we're going to adapt this in the future. Yeah, this is a recent development. And this is one of the paper that we developed and published already. And of course, using the artificial intelligence with explainable AI. In the past, everything is, you have to believe it. Deep learning, machine did everything. So what did you contribute? But nowadays people want to know why. And the explainable AI is one of the part of things that we consider at Khalifa, and we already published in this area. And explainable artificial intelligence to evaluate the industrial internal security for the brain waves and so on. So health concern about, for example, when you detect using EEG, you can detect not only the emotion, but also whether the athlete can be happy, sad, or stressed. All this signal can be collected in the future. Right. So this is one of the examples that we developed at Khalifa, and then we move on and we publish already in the using EEG for authentication purpose, but also it can apply for the fitness for duty. But now it's a fitness for athletes, whether it's able to person is to able to in the field of athletics event, whether this person is mentally fit to perform the duty or not. Especially like most of the games, of course, when you play golf, especially it's a kind of mental game. Whether you can able to control all the coolness and all this, and you can perform and win and things like that. So you need to consider this now. And now I'm going to talk about that is AI in the fitness, the evaluating the athletes' health, the health point of view, as well as that person is whether able to do the duty for the fit to the performing the in playing sports or of anything. Now I'm going to talk about more into esports. Esports is upcoming area. I think everybody want to play in the metaverse or the online games and so on. So esports is one of the area that into coming into place. And now the metaverse is a very interesting device that you can have wear a goggle, and then you can able to do augmented reality and virtual reality. We call it digital twin. So in other words, what you do in the real world, physical world, it can become a virtual world. I think I already mentioned last time the AI in education, but also it can be applied over here as well. Of course, the digital twins can apply it in the esports easily, because it's not only the esports is more online game, so they can able to duplicate it using the Google like metaverse device and so on. So you can interact. Why? Because when you have people will wear a goggle, and then they can collaborate and see the vision and so on. So metaverse gaming esports gaming is more interesting for this area. However, I'll talk about the blockchain application later. Okay, so blockchain application is very good for that, for decentralization and digital transaction and so on. Okay, but let's go into, these are the devices at the moment. And recently, the Meta, which is Facebook, former Facebook, okay? Now they developing the device, look like a glass, but it can, it's not become a product yet, but they are developing, of course. In the Apple, they are doing this, and in Korea, I'm worked with the Korean university like KAIST, Khalifa University and KAIST, and we work together to develop this kind of goggle, the Meta device, in order to have, for example, checking the iris, the authentication for ECG and EEG and so on. So multimodality authentication can be possible. Now, the metaverse esports technology, of course, data is a king. We want to collect all this data because they can keep collecting using the ECG and EEG and biometrics. For that, with the iris and the haptic environment, you can able to feel and get all the data accordingly at the real time. Okay, and also it is communicate with IoT device at the same time. So nowadays the data-driven metaverse world, and of course there are money involved, of course, in the blockchain technology. And according to this survey, you can see that the global monetization telecom market, you can see the year 2029, you have like a pseudo like that. So you can consider that. And now I don't have to, I'd like to introduce blockchain. And long time ago, we use hash function. When the hash function, hash chain is blockchain. But people doesn't like to use the name hash chain. They change the name called the blockchain. Is virtually the chain of hash. Hash function is existed donkeys years in 1940s, 50s, but they don't want to use the old name, hash chain. They want to use a fancy name like blockchain, but it is the same thing actually. And of course, it provides immunity, distributed network, cybersecurity, and transparency, and so on. Of course, the blockchain application is both, of course, because of blockchain, they're using hashing, therefore it provides decentralized solutions, of course, and it is distributed, not centrally organized. So it is good for that, and also enhance the cybersecurity capability. And of course, it can be tamper resistant and so on. And of course, this has all the ledgers, so that every ledger has with the hash value, with the same thing, recorded all that. So you can apply that in the esports in blockchain. Okay. Now, this blockchain technology, and these are the outcomes that can be, you can see that the prediction that you can see. So blockchain is here to stay, and I believe that the esports in blockchain application will come. Not at the moment, but in the future. I'm talking about in the future. So what I'm really interested in the blockchain, in the applying esports, and one of my PhD students and postdoc working on this area, and it's the initial stage at the moment. Of course, the esports and lack of course, there is real-time analysis required, and also at the end of the day, esports and real sports, there are fans. Fans are very important asset, and fans want to support Leonardo Messi, or the Son Heung-min, and the good football players that they want to support, right? At the same time, they want to buy a token to support the players and so on. So they can able to do this and provide solution for that. So one of the esports in metaverse is that esports become a major driving force, in my opinion, in the future. And also this is worldwide audience, because you don't have to be physically there. Anybody can join all over the world at the same time. Like, for example, in Korea we have K-pop, who the Blackpink, and they do the metaverse concert and so on. People love to join and buy a token of the tickets and so on. They start with the ticket now using NFT, but also they buy a lot of item in the metaverse environment. Nowadays, big, expensive, the Hermes and the other, the very important brand. They want to create the item in the metaverse so that people can purchase the clothes or shoes or from them and so on. So this is very intriguing. And of course, it have to be digital environment. And as you can see that we can have to monitor the, monetize and secure framework because, blockchain provide this cybersecurity and transparency for that. And of course, at the same time, this kind of tokenization will allow for seamless engagement between fan and the players because they want to interact, buying the item and supporting the item with the participant in the favorite athlete journey of new exciting way, because this is, I believe that this for the future. And also there are potential, of course, we have esports monetization in the environment involving subscriber is money. Who, in other words, Manchester United, supporters, right? They want to buy a membership, just like that. You can buy a membership and an asset in the metaverse environment, and tokenization and involve subscription can be, the blockchain application for that. So also it can apply in the, like, for example, the winning a specific asset on non-fungible token to related esports and their interactions and so on. So this is in one of the application that we could consider. At the same time, and subscriber can engage by purchasing point or the token that they can allocate to their favorite player. Okay, so they want to buy. So what's the supporter do? They support with the money or present, don't you think? And they will buy this kind of item for them, right? So so that it will direct the player and it boosts up their performance accordingly, influence athletes' performance, ranking, and visibility, and so on. So that is relating to that. So in other words, the certain player has more token than the other player, then it's like competing. Don't you think? So I mean that can be a exciting opportunity in my opinion, and engage the token, win an executive reward and so on, like a token. At the end of the day is a ticket and so on. And also gaming, is upcoming gaming or event change, like a chance to participate in this, and they give a free gift or give NFT ticket and so on to the to selected people and so on. Okay, so that can be very useful. Okay, so in my opinion, this can be very useful blockchain monetization of the esports in the metaverse. In my opinion, this is it will be coming in the future, and esports will be very hot in the metaverse because they want to, everything is online with 3D effect. And augmented reality and mixed reality can be present. Like, for example, internet is 2D. Now, metaverse is 3D. It's not suited yet. Somebody say to like a big player like Facebook or the Amazon or Google, whatever. They, whoever control the platform, control the money. So this is, in my opinion, is a hot topic. That's why the Facebook changed the name for Meta nowadays. Okay, so this is very interesting, and for that, I think the of course important is security. At the end of the day, I have all this technology. Without security, then we have an issue. But thanks God for NFTs and blockchain who provide the security, and is already proven and decentralized, and it's very useful. So these are the interesting point in blockchain technology. I'm not going to into that, but you can read some of my paper and Professor Ernesto paper. It's good to see Professor Ernesto in this panel as well, and he's my boss, and he discussed that in more detail previously. Yeah, and these are the integration process. In my opinion, this is step by step. You cannot do immediately. You have to have blockchain integration to develop the platform, obviously, and interaction and asset tokenization, NFT, also another stage. Subscribing interaction and data analytics and security transparency, on-chain, off-chain. This is ongoing research. And I don't have all the solution yet, but we are moving in that direction with because research is exciting, right? So I want to, to think about all this in this area. Okay. And this, in my opinion, that can be, good project for the, blockchain platform and AI-driven insight, scalability, and so on. And these are my publication in this regard. And thank you very much, and appreciate your listening. Thank you.
Thank you, Dr. Dr. Chan. Thank you so much for your presentation. And the floor is open for any question from the audience. So, Dr. Chan, is blockchain and metaverse technologies, are they slowing down or integrating under AI?
Good question, and it seems it's slowing down, but the thing is that always it was when it comes, it's a very hot topic, okay, and then later it's not become a hot topic like that. So in my opinion, when these things catch up, but currently we don't have the actual fully integrated device yet. Facebook mentioned they have some kind of Google, they have that, but the end of the day, it is the market driven. The end of the day, we have all these devices that happening. Currently, everybody is developing in the meantime. So when I see the device, then after that it'll sudo, in my opinion. But if you just watching, then nothing happened. In my opinion, it's like that. So it's I hope that in the future, but let's wait and see how the product has been developed. And for my research, I want to assuming all you do have, and then I'm researching ahead as a researcher. Okay. Thank you. Good question.
Thank you, Dr. Chan Yoon, Cybersecurity Leader of Center for Cyber Physical Systems at Khalifa University. Thank you so much. أعزائنا الحضور، ننتقل إلى متحدثنا الأخير لهذا اليوم، الدكتور أنتوني تشوبا، باحث في جامعة لييج ببلجيكا. سيتحدث عن مناهج من القاعدة إلى القمة لحل مهام الذكاء الاصطناعي المعقدة في مجال الرياضة. Ladies and gentlemen, we are moving to our last speaker of today, Dr. Anthony Choppa, researcher at the University of Liège in Belgium. He will be talking about bottom-up approaches to solve complex AI tasks in sports.
Hi everyone, my name is Anthony Choppa. I'm a professor at the University of Liège in Belgium, and unfortunately I won't be able to present live to you because of travels. But I would like to extend my gratitude to His Highness for the invitation, and also to Dr. Jassim Haji for the invitation. So today I will talk about a topic that I've been working on for some time, which is bottom-up approaches to solve complex AI tasks in sports. And particularly in this presentation, I'm going to give you different explanations, first on the introduction of what are bottom-up approaches, so with some computer vision basics, some data-driven approaches, and then I will define this bottom-up as a way to go through different levels of semantics. Now, to illustrate, I will provide you two practical use cases that I've worked on during my career here at the university, which are on game state reconstruction and on virtual banner replacement. And then I will present some limitations of such approaches and some conclusion. Now in his talk, Silvio Giancola, that you will meet later, will also present some top-down approaches, which are the converse of bottom-up approaches. So with these two talks, you will have a full understanding. Now, if you have some questions, feel free to ask them directly to Dr. Silvio Giancola, who will be there with you. So let's get started. And let's start with some basics. I always like to start these kind of talks by reminding a bit what we mean when we want to do some video understanding tasks and solve complex AI tasks in sports. So here, for instance, we see a football game of a match that was recorded on TV. Now for us, it is very easy to see where the players are and what they are doing on the field. But for a computer, the only thing he sees are numbers. And these numbers are usually stored into 3 channels. The red channel corresponding to the red color, the green one, and the blue one. And now the objective of AI is to make sense of those numbers that the computer actually sees. And so to do so, we develop algorithms that process those numbers and try to get some output. So let's see an example. Here, for instance, I'm putting a video of a game through an algorithm, and what the algorithm outputs is a set of bounding boxes around players to know where each player is on the image plane. Now this is very interesting when you want to do some player analysis, of course. And nowadays most AI approaches are what we call data-driven approaches. So it means that to train this algorithm to do the task that we want, so for instance here tracking the player, we will need some data to show to the algorithm. So we will need videos, but we will also need annotations of the end goal that we want. And so what exactly do we want? Well, there are several stuff that we might be interested in. And we've actually categorized them into 2 categories during my thesis, which are low-level semantics and high-level semantics. So first of all, by semantics, we mean useful information that could be interesting for analysis or for different applications. In low-level semantics, we represent everything that describes the scene. So for instance, here, where are the players on the image? What are the pixels that belong to the players or the pixels that belong to the goal? On the other hand, high-level semantics is more about the interpretation of the scene. So in videos, we know that there are some events occurring, there are some causes and some consequences. So for instance here, why did the referee give a yellow card? Asking that question and answering it actually represents some high-level semantic understanding of the game. Now, the objective of bottom-up approaches is actually to leverage those low-level semantics. So like I was saying, detecting the player, knowing where the field is, maybe understanding a bit the motion, and go towards this higher level of understanding by leveraging those low-level semantics. So typically, we have these bottom-up approaches that are compared with top-down approaches. So like I said, for bottom-up approaches, we go from low-level semantics, where are the players, towards higher and higher levels of semantics. So for instance, how are they moving on the field? And then, what are the actions? Can you describe what is happening in the game? For top-down approaches, it's completely different. Then the algorithm acts as a black box where you put at the input the video, and then at the output you expect exactly what you want. So for instance, all the players detected, all the actions, or something else. So these 2 approaches actually have advantages and limitations, each of them. So let's see a bit what they are. So first of all, for bottom-up approaches, they are extremely interpretable. Why is that? Well, because we are already providing the way to separate this complex task into subtasks that are much easier to consider and to solve. So this follows a clear hierarchy in the task. And so if some module, for instance, fails, we directly know which one it is and we can replace it or improve it. On the other hand, for top-down approaches, well, they are not as interpretable. Like I said before, models usually act as black boxes, and so when something goes wrong, we don't really know how to solve it. Another advantage of these bottom-up approaches is that they are modular. And by modular, I mean that imagine that you want to solve a complex task, like game state reconstruction that we'll see after, and you need to develop some module. Well, those modules that you develop, you can then reuse them in different tasks, and we will see how we do that. Now, for top-down approaches, this is not possible. Usually, the model is trained to do one specific task, and that's it. It cannot do more. Also, bottom-up approaches are often less computationally expensive, while top-down approaches require huge amount of data and typically also a lot of computation power. And for bottom-up approaches, we will really focus on learning fine-grained and local patterns. So like I was saying, which pixel belongs to which object is a very local pattern to solve the task. And for top-down approaches, they are susceptible to overfitting and also learning dataset-specific shortcuts, which might be an issue. Now, this is not a perfect world for bottom-up approaches. So for instance, going towards very high levels of semantics is usually very difficult with bottom-up approaches. Why is that? Because, well, simply, sometimes you need to put a lot of effort in designing that hierarchy in order to solve the task. And while on the other hand, top-down approaches, well, they directly solve the task that you want. Also, if one of the modules fails in bottom-up approaches, well, the whole pipeline may fail, right? And usually, top-down approaches are more robust to specific noise. Now, it also takes a lot of time to feature engineer these bottom-up approaches for each task. This is a real limitation sometimes for very complex tasks. And also, overall, when you're trying to solve these very high-level tasks, well, they may require a lot of global context that can be very difficult to design in the pipeline. And overall, well, top-down approaches have also shown strong performances in end-to-end learning, but for specific tasks only. So let's see a bit what they are through two use cases. And I will start my first use case with the task of game state reconstruction. So let me show you what it is. In game state reconstruction, what you put inside the model is a broadcast video. So typically like the one you're seeing here, where you see all the players moving. And the idea is to ask a model to produce an output that is a top-down view, top-down radar view of the field. So here, for instance, all the dots corresponding to the players on the team on the left or on the right, all their jersey number, where is the referee, for instance, and might also be interested in the ball. So here the idea is to predict for all athletes on the field their location and also identify them. So if we went with top-down approaches for this, it would be actually very difficult. Imagine that the model really has to go through directly the image space or the video space towards this very compact representation of where the players are on the field. Well, first of all, if something goes wrong within that model for some reason, it's going to be very difficult to understand at which point the top-down model will have failed. And this is because the top-down model, all it does is take the input video and just output something, but without clear reasoning that we can understand. Also, this model will need to be trained on a very large database, and if for some reason, like the jerseys of the team change, or the numbers, the way they're written, they change, well, the model might not be able to adapt very easily. So overall, it will have poor generalization. Also, we've seen with these models that they can sometimes hallucinate. So for instance, they could present a game state that doesn't make sense at all with respect to what is available on the video, and basically that would not occur in a real match. And the final one, and I think this is one of the most important one, is the temporal discontinuity that we observe. Usually for generative models, but also models working on very long video sequences, it is very difficult to ensure that the output will be temporally consistent. So this means that, for instance, team formations will not randomly split at some point during the processing of the model, and that will lead to something very unusual. So the way we decided to approach this is to go, of course, with a bottom-up approach for game state reconstruction. So as you can see here, we show the different steps that allow us to go from the video towards the minimap that we have. So here you can directly see that there are the players that seem to be localized somehow in the image. You also see the field lines that are localized, and also the jersey numbers that are recognized on top of the bounding boxes. Now let's see concretely how we did it. Well, like before, we are providing videos into the model that is called TrackLab in this case, and that will produce some output. Now, of course, to train the model, we still need some videos. So for that, we collected a data set of 200 videos of soccer games. Then we need the model. And we decided to make this baseline, so this first way to solve the task in a bottom-up way, open source to the public so that people can continue working and improve the modules that you will see later. And finally, we also had to define how to evaluate that task. And so we had to propose a new metric for that, which is called the GSOTA. I will not go too much into the details of the full benchmark, and I will really focus on the method part now. So let's see our bottom-up approach. Here, you can see that the image is going through several modules that are represented by those boxes. If I take the pipeline on the top, you can see that the images of the video are going through a first pitch localization module. What this will do is that it will extract where are the lines on the images. And for that, we actually use a method that was the winner of a camera calibration contest that we organized the year before. So this means that we could reuse something that was developed by the community directly inside of this new baseline that is solving a new task. And then these pitch lines are going through a camera calibration module that was also proposed the year before. And basically, this allowed us to have a transformation matrix that would go from the image plane, so the 2D image, into the real world. Like, what are we, where are the players exactly on the pitch? Now, if we go through the bottom one, now we are in the detection pipeline, more for the players. Here you can see that for a detector, we decided to use a YOLO architecture, which is a very popular architecture that was developed to detect people on different type of images. Now, this is very interesting because we were able to reuse something again that was available. Then this can go either through a re-identification part, a tracking part, or a jersey number recognition part. And this will basically provide the team affiliation, so in which player does it belong, the team on the left or the team on the right, some tracklet, so the following of the players over time, and also some consistency mechanism to make sure everything is well localized. So now what we can do with these 4 outputs is actually to recreate our game state reconstruction map, so the top view of the field. And this is very, very interesting because if at some point one of those modules fail for some reason, we can diagnose it and eventually improve it. And I will show you that later on. But let's see first what are the results of such a pipeline. So as you can see here, this is our baseline that we proposed for our 2024 SoccerNet challenges last year. And people were given this to work on and improve. So of course, there are some players that are not recognized, as you can see with the X's. And also, sometimes the camera calibration fails a bit, and so the position of the player is not perfectly represented. So now, we organized in 2024 a challenge, and in 2025, again, another challenge on this. And as you can see here, compared to the baseline that was placed at the 11th place at the end, there have been 10 other methods that were able to improve. And I can tell you that out of all of those 10 methods, well, all of them use the bottom-up approach. None of them tried to solve the task directly end-to-end. And this is because, well, they could rely also on our baseline to improve specific modules. So for instance, the first one could improve the athlete detection part, and the second one improve the camera calibration part. And what is really interesting when we see a bit what were the novelties inside that challenge is that actually all the modules have been improved by some of the teams. And so what can we do then with all of this information? Well, let's reuse the best detector for players from maybe team A, and then the best camera calibration from team B, which is very interesting because we can merge back and create a very strong baseline for the game state reconstruction task, where we will have the best submodules that are solving the task. So this was all of our finding on this first use case. Now let's have a look at the second use case, which is one that I worked with a student over the past year, called Virtual Banner Replacement, and that will be presented at the CV Sports workshop in June. So in this work, what we wanted to do was create some end-to-end pipeline for virtual banner replacement in football broadcast. So let me show you what I mean by that. Here you can see a regular football match going on, but actually what we can do is whenever I want, I can decide to change the advertisement board. So for instance, here I put a logo of my university, the University of Liège. But I could also put something about my project, SoccerNet. And this is really what we wanted to achieve, being able to replace automatically in any broadcast footage the virtual banner. So the first thing we figured out was, okay, what should we do? Should we do a top-down approach or a bottom-up approach? And what we've seen actually with top-down generative AI algorithm, which replace content or create content, is that sometimes they work well. They can create some plausible content, so like you can see on the left, but also a lot of the time they will generate something that is really unrealistic. And for this, we really needed the blending to be seamless, because we don't want to catch the eye of the viewer that we're passing some advertisement. It should be subtle, should be seen, but still subtle. Now there are some challenges with these top-down approaches. And the first one is that we would have needed a lot of computation power. This is typical. And like I said before, one thing that is very, very hard to ensure is the temporal stability and smoothness of the output. We don't want the banner to shift directly at some point towards something very unrealistic. And the last thing is that it should be physically accurate, because otherwise it will directly catch the eye of the viewer. So, as you can imagine, we decided to go with a bottom-up approach for this banner replacement problem. And so the way we did it is that we had 3 modules. The first one, on banner segmentation, would actually try to localize a very low-level semantics, which is which pixel belong to the advertisement banner. Then we also have camera calibration, so this is just like before, to go from the 2D world to the 3D, so to follow the motion of the banner. And the final one is the compositing stage, where we will actually replace pixels that are identified as banner and with the correct logo by following the motion provided by the camera calibration. So let's have a look at the first module, so the module of banner segmentation that we have here. As you can see, this is the output that we can generate. And so the banner is overlaid with some blue. All the players and all the objects that come up front are called occlusions, and these are colored in red, and the rest is colored in either green for the goal part or in black for the background. Now, of course, we needed a dataset to train this model. But now, instead of having to require a dataset that goes from video with some advertisement to another video with different advertisement, all we needed was the position of the banner within that frame, which is much more easy to capture. So by dividing our big task into a subtask, we actually also reduce the complexity of the dataset that we needed to build to solve the task. Now for the second part, camera calibration, like I said before, we could reuse something that was developed, and we actually reused the top method that had the best camera calibration for the game state reconstruction part. And so this is what you can see here, the output of this. And you can see that it is still a bit shaky. And actually, when we replace the banner, we could notice this shakiness. And there are also some issues where here you can see that at some point, the camera calibration just fails and cannot retrieve. Well, what we did is that we decided to improve this specific module because we knew in which cases it failed. And so to do that, we worked a bit on some signal processing parts. So I'm not going to go into the detail, but basically we smoothed out the signal so that we can have something more smooth and more pleasing to the eye. And so here you can see the difference on the left without the filters that we added and with the filters that we added. Of course, this is much smoother now, which was our objective. And so we have actually also been able to replace the camera calibration parameters where it failed before. And so with this, we actually improved the camera calibration. Now for the last part, the compositing, we actually managed to do a few tricks to make it seem a bit more seamless. So first of all, we derived a general banner model, like a 3D banner model around the field, to actually correct when sometimes our prediction model went a bit above the actual banner. And so for that, I'm not going to go too much into the details, but we used a few mathematic tricks to actually realign every time the logo with the actual banner. And so as you can see on the right, it's much more smooth and much better in terms of vertical motion of the banner. And the last part is on the blending itself. If we just put the logo as it is, well, it would look very bright compared to the rest of the image. So we actually used a few tricks here and there to actually blend the image a bit better. So as you can see here, before and after. Okay, so now we've seen how we can actually leverage bottom-up approaches to solve complex tasks in sports by reusing some stuff that were developed by the community. Now I'm going to show you that it's not a perfect world where bottom-up approaches are the solutions to everything. So here I'm going to first show some limitation, and for that I will use one use case of action spotting. So let's see a bit the limitations. In this action spotting task, the goal is that I provide you with a full video, and the goal was to retrieve some specific action. So at which frame does a specific action occur? And in this case, we were interested in headers. So headers are whenever the head of a player hits the ball. Now we figured out, okay, why not try a bottom-up approach on this? So first, we could reuse a detection algorithm, so like the YOLO one that we use for game state reconstruction, to localize all the players, and then also detect the ball to see if the ball basically was close to the head of the player at some point. So here you can see that during a header event, yes, of course, it works quite well. The detector detects the ball and it is close to the head of the player, and so it is probably a header. Now we can see some qualitative results of this. So first we have a header, that's fine. Here we have a second header that is detected. And then we have something strange appearing. Here we don't have a header, but still the model proposes that it's a header. And here again. So what's actually happening? Well, not all balls that are close to the head are actually headers. So for instance, in the first case, the player actually got the ball on her chest and not on her head. In the second part, the ball is just flying around, but it's actually not close to the player. It's a trick from the projection of the camera that makes us think that they are close. And the other cases, well, sometimes other things can be detected as a ball, like the microphone at the back of the stage, or for instance here, the hair of the player. So we tried to go a bit deeper into the understanding. So why not use pose estimation? Well, pose estimation can work. You have a better sense of where the head is located. And so you can most probably say where the ball is compared to the head. But you still have some issues. So for instance, when in low light conditions, so let's say the player runs into a shadow, well, sometimes the pose detection algorithm just doesn't work. Also during high motion blur, well, detecting the player could still be feasible, but detecting the pose becomes very hard. And this motion blur is actually something that really prevails this bottom-up approach based on pose to actually work. And actually, if we compare this to architectures that have been proposed, so top-down deep learning architectures, the performances of these top-down approaches are much better. So we're talking like going from 11% of performance to 62% of performance, and even nowadays up to 85% for some algorithms. So my takeaway here is that, well, while this can be very interesting for solving complex tasks, sometimes the data or the algorithms are just not there yet to go towards a bottom-up approach, and leaving the deep learning model, the black box model, decide on its own might be the best solution, unfortunately. So as a conclusion, we've seen that these bottom-up approaches are very interesting because they are interpretable, they are also modular, and they can be reused. So if I develop something for some tasks of game state reconstruction, it doesn't mean that this will stick forever to game state reconstruction. So this could be very interesting because you don't spend money just solving one task, but potentially building a strong libraries that will help you solve many different tasks. Now, for complex tasks where deep learning approaches require some temporal consistency and some generative capabilities, I still think that those bottom-up approaches are very interesting, and especially in the case of challenges. When you want people to build the best model for something, it's much easier to work on a subtask and improve the overall performance than to start from scratch every time that you want to propose a new model and you have to test whether it will work or not without having prior knowledge on why it worked or not. But still, deep learning has shown that top-down approaches really prevail in some tasks, so for instance, action spotting. And Dr. Silvio Giancola will talk a bit more about these top-down approaches and how we've used them in different scenarios afterwards. So thank you very much. Like I said, I'm sorry for not being able to join today. I would have loved to answer your questions, but feel free to ask them to Dr. Silvio Giancola. And thank you once again for His Highness and Dr. Yassim Haji for the invitation for today. And I look forward to seeing you at the next event. Thank you very much.
السلام عليكم ورحمة الله وبركاته. وكرر اعتذاري كما ذكرت سيدة دلال. والفيديو سوف يطرح عليكم إن شاء الله في وقت لاحق. أود في الختام من لغتين، بداية باللغة العربية. I would like to end with both Arabic and English closing ceremony. نشكر مرة ثانية على رعاية سمو الشيخ خالد بن حمد آل خليفة، من الأول المجلس الأعلى للرياضة الشباب والرياضة، وأيضا رئيس الهيئة العامة للرياضة رئيس اللجنة الأولمبية البحرينية، وأيضا الكلمة الافتتاحية من سمو الشيخ سلمان بن محمد آل خليفة نائب رئيس الهيئة العامة للرياضة دكتور عبد الرحمن العسكر والفريق على الدعم. سوف إن شاء الله يكون لنا مؤتمرات قادمة حضوريا في الذكاء الاصطناعي، وبالأخص بإذن الله في شهر يونيو القادم، وأيضا مجموعة من الكواكب البحرينيين سوف يتم للسنة الرابعة تكريمهم في دعم الذكاء الاصطناعي، من الرؤساء التنفيذيين إلى مدراء التنفيذيين في مجال التقنيات والذكاء الاصطناعي، وذلك دعما لطروحات الذكاء الاصطناعي في 6 مجالات في مملكة البحرين والتطور الدائم. وأيضا مثل ما سمعت اليوم عن أطروحات سوف نعمل جاهدا على تطبيقهم، وليس يعني فقط الاستماع إلى الخبراء أو المتحدثين، إنما علينا أن مثل ما طرحوا الزملاء من الجامعات أو من الشركات المهنية جلب البيانات. علينا أن نعمل على تنظيم البيانات المخصصة، ذكرناه في البداية وفي النهاية، وتكون أسس تطبيقية لأي حلول في الذكاء الاصطناعي. وأيضا مثل ما ذكر الأخ بروفيسور أرنستو، النماذج اللغوية الكبيرة Large Language Model المخصص للبحرين ولا الرياضة، حيث الرياضيين ممكن يتفاعلون مع الشات جي بي تي المصغر لمملكة البحرين في الرياضة، حيث الاستفادة من توجيهات أو من البيانات المتوفرة لكي يقومون بممارسات صحية وفنية وسليمة أكثر دفاعاً. وأيضاً تحدثنا عن الحوكمة في مجال الذكاء الاصطناعي، هذه الخطورات الناتجة من الذكاء الاصطناعي أو خوارزميات غير دقيقة، فيجب يكون هناك إرشادات ونعمل ذلك مع الهيئة العامة للرياضة لكي يكون أساليب متطورة وأيضا سليمة ودقيقة في هذا المجال. وأيضا تحدثوا عن الرؤية الحوسبية أو كمبيوتر فيجنز أو LLM فيجنز، حيث جمع البيانات والصور من اللاعبين في تمارين في جميع المسابقات، من ثم الاستفادة من الذكاء الصناعي للتكهن والتنبؤ بالمستقبل وكيفية التعامل معهم. هناك عدة توصيات، عدة فروقات. أيضا من المتحدث الأخير اللي كان يتكلم عن بعد وطريقته، سوف نعمل على جمع كل التوصيات وأيضا الخبرات المتواجدة. هم سوف يكونون معنا على مدار السنة في تفاعل عن طريق التواصل في موضوع الذكاء الاصطناعي وتطوير البحوث في الذكاء الاصطناعي. واحنا في مركز سمو الشيخ ناصر للبحوث والتطوير في الذكاء الاصطناعي وأيضا المجموعة العالمية للذكاء الاصطناعي يكون اهتمامنا في تطوير الذكاء الاصطناعي. والسنة القادمة إن شاء الله أو المناسبات القادمة سوف نرى بعض التطورات الإيجابية من مرحلة النظرية إلى التطبيقية. Finally, I would like to thank my colleagues, the speakers from different parts of the world, and apologies for the recorded video not being audible at the time by the operator, who should have done a better job in testing it prior to this, but this have occurred, which we will fix. And however, the link is available for the audience to request and be shared. We have very valuable and useful recommendations and outcome for us to take forward, including how do we govern and put guidelines for AI in sports, not prohibiting or putting roadblocks in terms of AI developments in the country, but also the legislations and the governance of it and how this can be promoted without harming any parts of the sports or the sportsmen and women. We also look at the wearables, how that can help, computer visions, LLM visions for the data detections, and as multiple speakers mentioned about the importance of the structured data and the governance of the data, which is key to our future AI development and various technologies. We're also looking at agentic AI and AI agents. Well, it can collect data from multiple sources and have more accuracy and autonomous decision making using even reinforcement learning. That will be the future where we rely more on AI on decisions in terms of administrations and technical committees. شكرا لكم مرة ثانية، ومرة ثانية نرجع لأستاذ دلال. شكرا.
نشكر جزيل الشكر الدكتور جاسم حاجي رئيس المجموعة العالمية للذكاء الاصطناعي. وفي الختام أعزائنا الحضور، نشكر سموكم الكريم بتشريفكم عرضنا هذا، على أمل اللقاء بسموكم في ندوات أخرى بإذن الله. كما نشكر جميع الحضور والمشاركين على دعمهم ومشاركتهم الفاعلة، مع تمنياتنا للجميع بدوام الصحة والعافية، ودمتم برعاية الله، والسلام عليكم ورحمة الله.